That's really amazing because what you're doing here is you're creating a string that actually is an error message, and like you're kind of making your own TypeScript compile errors, like you're kind of plugging TypeScript on the fly. How do I do this in my libraries? This is super good. This is a great user experience.
And the eternal challenge that the ecosystem has kind of done several iterations of evolution on is like, oh no, we already have types defined. We need to do validation. How do we avoid duplicating our types? It's the last thing that you want to duplicate because it's really, really likely to cause bugs and like crashes if there's any kind of desync between like your types and your validation.
Welcome, everyone. So happy to have David here. David's the author of ArkType. And what we're going to do today is go through all of the things that are, that need to take place for ArkType to happen, what it is, how it works, who it's for, all of those kinds of things. So this is a project showcase. And, David's going to be running most of the kind of directing us. I'll be asking questions along the way. So, David's around. If you have more questions and you'd like to know more, we can continue the conversation. But the hope is for this call is to be a fairly technical and pretty deep dive into what it is that ArkType does and how it accomplishes it. David, could you introduce yourself, please?
Yeah, sure. So my name is David Blass. I've been working on ArkType full-time for about a year and a half. So it's been something I've been incredibly passionate about. I was like pretty deeply into TypeScript before that. I was actually working on what's on this shirt. It says Redo, which was this web UI testing related tool that I was building. It was also an open source tool. And then, of course, like as any, good open source developer would, as I was building that tool, I was like, what would really be helpful is like a state management tool that, used TypeScript types that could be inferred at runtime. And then it's like, well, I need to build this validation that like mirrors TypeScript's own syntax. And of course, I just went down this ridiculous rabbit hole and ended up building this whole type system and validator. But I think like looking back on how it all happened, I'm very, very lucky that it did. It's just been something that I've been so passionate about. Have probably been working on this project, 80 or 90 hours a week for that year and a half, just out of like such deep fascination with type systems and, the limits of TypeScript, and just kind of pursuing like realizing the sort of initial vision that I had that has kind of developed over time since then for this, really deep runtime adaptation of what TypeScript does. So that's always been my goal. And it's really exciting to sort of see some of that coming to fruition now.
That's awesome. That's a great journey. How did you come up with the name for ArkType?
Yeah, so I'll click over to the website here. It's like kind of subtly illustrated, but essentially the idea is like an ark as like a boat that, takes your types from, compile time in your editor and TypeScript to runtime, and it's hidden by the like installation block here or whatever, but it's a bunch of JavaScript runtimes like Node and Dino and Chromium and it's JS. So basically the idea is like it's TypeScript you can take to runtime instead of the types being washed away by the flood of compilation. They're saved on this ark. I would like to at some point add some like cute little syntax animals or something on there. Like, you got some like pipe operators for unions and maybe some like map types or something in there, and they're kind of walking around, but it's a little bit outside my my area of expertise. So for now, it's just a boat. But yes, it's that, and it's a play on the idea, obviously, of like an archetype and just that idea of like a single type, that sort of like crosses the boundary of compilation and potentially eventually would also cross language boundaries and things like that. As a serializable syntax, I think it has some really unique potential to expand in ways that a lot of pure like JavaScript validators couldn't.
Mm-hmm. Yeah, the type erasure part of TypeScript is always kind of interesting to me because there's so many languages where it doesn't. I mean, you can pass a type as like a thing. It's like something you can work with because the language can depend on it being there. And of course, TypeScript can't have anything like that because have you heard of the proposal to add types to JavaScript?
Yes. Yeah. No. I mean, that is something I think is really exciting. Of course, for a long time. I've always wanted a repo setup where I didn't need a build step, for example. I think that's a thing that a lot of people want to pursue with like Dino and Bun. And, I have something kind of like that just using TS Node and like local execution. But, there's always these caveats. There's always the like CJS, ESM, whatever nonsense. If you could actually write JavaScript files and annotate them, with types, I don't know the limitations, and maybe they're still sort of being iterated on, but like I don't know the exact limitations of what kind of type syntax will be available. But like if it's fairly close to the original TypeScript, that sounds incredibly powerful and appealing, specifically from the perspective of ArkType. It may allow us, depending on the sort of like runtime reflection capabilities, if you can like extract the string that was used to define the type, then we could potentially like have validators that would run based on just like native type annotations, which of course would be really cool.
All right, I have a bit of a hot take for you. So I worry about adding something like that to JavaScript because in my mind these days, JavaScript rather, like the one that runs in the browser, is kind of like an intermediate language. The same way you have Java bytecode or in C# or whatever, you have like the .NET intermediate language that F# compiles to, that C# compiles to, and so on. It means to me that all of this progress that we've had on TypeScript would have to slow down in some ways because it would be restricted on the runtime semantics, not just like, type string, means something, but actually TypeScript typing something as string has changed because we have strict null checks and, other things. But
I haven't been really around in the ecosystem quite that long. Like I know TypeScript has been around for like 11 years now, but like coming into it a little bit later because I was working in Python before this. And I really started like investing a lot in TypeScript probably, 5 years ago or somewhere in that era, maybe a little bit earlier.
Gotcha.
But like essentially, when I learned that was even an option, that like by default, you can assign null or undefined to any variable, I was like, what the F, is this? Like, this is supposed to be a type system. Like, you can't do that in a type system. Yeah. That's insane. And I still see people getting bit by that quite often. So I feel like if they could go back in time, maybe they just never would have added it in the first place. But with some of the kind of like legacy stuff we inherit, I know they don't want to make breaking changes. And for the most part, with some basic setup, you can get a much better environment to work in now. But would highly recommend that people do enable that setting in strict mode in general.
So do you think there's a future where ArkType could be kind of obsoleted by the language having some of this validation built in the first place?
I think it's pretty unlikely based on the feedback that the TypeScript team has given in this area. Because I don't know if you've seen the like GitHub issue of this. This is like very let's see if I can find it. GitHub, TypeScript, runtime, validators, something like this probably.
You're a fast typer. I'm very impressed.
Thank you. Let's see if I can actually find it here. There's this like, oh Jesus. It's not this one because this is some specific.
That's okay. But yeah, what is it broadly?
I guess maybe I would have to. You know what? If I like search within GitHub, let's just see. So I'll go to the TypeScript repo, and this is like very ranty issue about like look how many runtime validators have been created, and let's just. I mean, maybe I should just have searched within issues directly.
While you're doing that, I'll tell people like. There are examples of this that have worked really well, and the one I like to cite is Elm. So there's a language called Elm, or I think it's elmlang, if you want to search for it. ELM.
Yeah, sure. This is probably better. I don't want to waste too much time searching for this.
No, that's okay.
People can find it, and I can link it later. But
Elm takes the approach of like having as brutal as possible the constraints on the soundness of the type system. And so, like, I think it's still true today that there has never been a type error in Elm. Like, in any Elm program has never, ever, that anyone has ever written has had a type error. And the reason is that what Elm does is it, like, very strictly sanitizes any inputs that come into the program for the types. And you can't really, it can't be wrong. Like, mathematically, it's like a provable type system. And there's no hole there to squeak by. And
So that's very cool. And I think there's definite trade-offs between like really strict statically typed languages and something like TypeScript, where casting, if you want like really type-safe APIs, particularly with some level of complexity to them, like you absolutely have to cast. I would say that my like number one pet peeve with the TypeScript community is that there's this like intermediate stage of TypeScript where you're like, TypeScript is so great, I should just be able to get it to infer everything naturally. And I will just use like type guards, and I will just like teach it to do, not that type guards aren't useful in certain situations, but like if you think that you will never need to cast and you will never need to like, have any lack of complete type safety in TypeScript, you're going to have a very not useful API, because there's like very little that you can actually do without running into some situations where you're going to have to cast. So I think like there's also, of course, the sort of opposite side of the spectrum where like as soon as you see a type error, you're just like as any or something, right? And then that's also a disaster for sure. But there's definitely a middle ground where like you look at a type error, you try to make sure that you can parse it and understand it. And if there's a specific reason why you know that like, okay, TypeScript should be able to infer this here, but it's like not in the language's current capabilities to do that. So like it's okay to cast in that situation. I'll just tell anyone who's listening in case that's like, it is okay. I definitely went through a stage more like that where I was like really trying to like work around it and just get it to understand. But like in the end, if you already know, like, and it's very clear in the state of the program that like a variable is going to have a certain type, like, and you create a bunch of extra ceremony just to make sure that TypeScript infers that in like a way where you can, obfuscate the fact that you've essentially cast it somewhere. I would recommend against doing that and, free yourself of that burden if possible.
Totally. Well, I mean, let's tie that back into ArkType. I mean, what would be the first thing that you would tell someone to use ArkType for? Like if you had a like elevator pitch, what do you think is like the best use case that shows its power?
Yeah, I mean, I think the best use case is just runtime validation. I don't think, I think that when I first started introducing it, I was like, well, it has like so many capabilities and it's just got all this depth to it. And it does. But like realistically for the vast majority of people who would use it, they would use it in place of something like Zod to validate runtime data. It can do a lot of unique things that other validators can't do, mainly like having a type system like built into it so you can compare two types to each other is definitely unique. And that allows it to like optimize the way the validation is done, and it allows you as a library author to do a lot of like meta level stuff. But fundamentally, like for the vast majority of users, if you're just thinking of like, what would I do to use this in my application directly, it would almost certainly be runtime validation.
So let's look at one. I mean, do you have one handy that we can kind of dissect?
Sure thing. Yeah. So I have realized over time that this example that I included in my GIF here is probably somewhat overwhelming. You can click this button, which is also terrible UX, and like it will give you a live editor environment where you can mess around with the demo. But there's sort of still a lot going on with this type. It does not look that much like TypeScript because I'm trying to showcase like a ton of different things at the same time.
Could you zoom in like 3x what it is now?
Yeah, I'm probably just gonna bail on this example though, because I actually think that this one is a little bit more approachable. It's like an intro is what I've found. So this is if you go to like docs and then types, this is like a more straightforward one-to-one with TypeScript. There's nothing crazy going on here. So I will zoom in and actually I will just open this on Stacklets directly.
That's awesome. Yeah, or even if you can like full screen it or anything, you can. I always like to, people who watch the Michigan TypeScript channel know I'm always conscious of people watching on their phones to try to like.
That makes sense. Yeah, like get rid of
make it accessible to them.
Great. Okay. So basically you can see this is like a basic ArkType definition. So we have this environment set up, which I think is like a really nice way to mess around with ArkType. You can access it if you just go to the arktype.io and you like click on the docs. They have these examples in Stacklets, and you can click edit on Stacklets if you want a larger environment here. But basically the nice thing about it is we just built like a little UI where you can see the definition that you passed in, and then you can see the result from validating this data. So it just gives you a little place where you can try out whatever syntax you want and get immediate results. So you can see here this type, which the original principle of ArkType was to mirror TypeScript syntax one-to-one or like as closely as possible in a runtime environment. So that was like what we sort of built all this from. We just thought, okay, like looking at how you define a type in TypeScript, you would say like if I wanted to define this type, I would say type user, name, string, and device, and then there'd be another nested object literal like this, and then platform would be Android or iOS, and version would be number. Okay, so this is what the TypeScript version of this type would look like. So what we did was just say, like, how could we make a runtime object look as similar to this as possible? And it seems like the most direct way to do that would be to embed the keywords and syntax in a string, and then everything else you preserve the structure of like the objects, and it ends up looking very similar. You got the same like type keyword here, and the great thing is obviously that if you mouse over the definition, you get this like very, very clear.
That's awesome.
You get the inference, and everything is one-to-one. So I think that like there's a lot of benefits to this. One of them is that a lot of the time, if you're using like a chain validator syntax, which is really common, and you want to know what the type of your validator schema object is or whatever, maybe you'd even be able to see it by mousing over it. Sometimes like that's not really enough, and you need to use some like special inference method or something like that to kind of like extract out what the actual type is. The really nice thing about this is you don't even need to mouse over it to see what the type of this is going to be, because it literally looks just like TypeScript. So there's like you don't really even gain that much more information by doing this. So like instead of having to take in the extra context of like, let me stop and hover over this to see what the actual shape of this object is going to be, it's just right there, and there's like no extra processing that really has to be done. So I find that to be a pretty big advantage.
Can I ask two tough questions?
Sure.
So if I put str instead of string on line 13, what would happen?
So you get this type error. So this is something that I originally tried to call an isomorphic parser. And people did not like that because they're like, isomorphic means on a server. And, that was one like adaptation of the word. So my idea for it was like, it works the same way.
People need to relax.
Within the type system and also like at runtime, which, I thought was like a fair adaptation. Nonetheless, I stopped using that word for that reason, which is fine. But essentially, we have the same parser implemented like within the type system and at runtime. So you can see that the error on the right is, so we actually made a little optimization to it where you get autocomplete. So in this case, you wouldn't get the exact same error because I was like, it's really nice to get string. I mean, well, I'll show you. But if you do start typing something like this, you get autocomplete for like anything in your scope.
That's cool.
With that letter. Yeah. And then and same thing, even within an expression, you get it. So like if I start typing n, it'll say like semver or null or number or whatever.
Wow.
So I was like a little bit, you can see now you get like a thing about really Alan Turing is not a valid semver, which it seems true. Essentially, I was actually pretty hesitant to add autocomplete initially because the way that the parser works, just to kind of like demonstrate something a little bit more concrete as like a syntax error. If I do this, like that's a syntax error. That's not like something I can I could actually say like maybe you want to finish typing that operator, but like that's essentially
the right bracket is not a thing.
Right. So you can see that like in the case where it's any kind of like parse error or anything like that, you're going to get an identical result. So like the type tells you missing expected, right square bracket or whatever you want to call it. And the same thing at runtime. There's all the tests actually use this utility that I built called throws and has type error. So it checks that the thrown error has the exact same string result that it contains as the type error. So that's like a really nice way to make sure it's literally one-to-one, like down to the character. Okay. So yeah, that's definitely a really nice feature.
My second tough question is on line 16, does that mean that if I have a property that happens to include, this is a crazy question, but just curious for fun.
I know what you're going to say. You're going to say that what if a property
has
a question mark and you can escape it?
That's just how you solve that, and then cool. I love it.
You can see here now that it says device version question mark must be defined. So yeah. One of those really like cool. Crazy edge cases. I think I'm like very perfectionistic and obsessive. So like I get those questions a lot because I think the kind of people who are interested in this kind of thing are also kind of perfectionistic and obsessive. Okay. But like busted. I was like so paranoid. I feel like when I was building it, I was like, let me think of every possible. I was like really like trying to guard against anything that could possibly, like even if someone was engineering something to like screw it up, I was like, I will find a way to make sure that this is perfect. Of course there's going to be bugs in the end. And like someone did find one that was kind of in that vein of just like some ridiculous thing where, you have a scope and you define a type called like unexpected something, and then you put another type called C is something, and then there's some way where you can like create something that's like not really, it doesn't show up as a type error, but it should be. Then it's just a runtime error, obviously. But like, those kinds of things are super fun for me to think about, and we try to do a pretty good job covering them.
Yeah, that's awesome. I'm kind of glad that I asked now. It's nice to know that you have that approach to building this. All right, but I have so many questions I want to know about. Like, I want to see the code for how you get the autocomplete to work with like string or number. But like, let's finish the example, lest I get even more distracted.
Yeah, that makes sense. So basically, the idea is that when you create this type, you can call it directly as a function, or at least that's like the default way that it's used to validate any arbitrary data. So it's unlikely you're going to be passing in an object literal like this in a real situation. It's going to be like data from a server or something you read from a file that you don't already know what the type of it is. But just for the sake of this example, it's just an object literal. And then you get back these two typed possible results that are discriminated. So it's data and problems. So data is the validated data of the expected type. And problems is an array of these like problem objects with some nice optimizations around problems. You can use like, so basically, if I say if problems, I'll go down here, then I can say like, console log problems dot summary. So that's like a nice like, concatenated version of the error message. You can also like iterate over. You can also like iterate over them and do other stuff like that. So you can see that it's logging it here. It's probably reloading like every time I type a character, which is why it's there 12 times or something. And then otherwise, like in this else branch, you'll see that I can console log data, but if I mouse over data, well, it should know that it should know that it's not defined. I don't know if there's some issue in the stacklets environment, or sorry, that it's not undefined at this point. I don't know if there's an issue in the like stacklets environment where sometimes there's issues with like the TS config or something not loading.
Sure,
so it's like, it won't narrow it for you. But basically, it's a discriminated union where like if you check the truthiness of one of them, you'll get, well, you shouldn't do it on your data probably if it could be undefined as like valid data as an edge case, but you should just check the problems. And if there's no problems, then the data will be whatever the expected result is. So if I were to then go back here, what this is summarizing is like, here was your input definition. And then the result we get for passing in Alan Turing, and then the device has a platform of Enigma. You get this like problem summary that says device/platform must be Android or iOS, and it was Enigma. And so as you can imagine, if we went and we changed this to be a valid input, then it would give a valid data as output.
That's awesome.
So that's pretty much how the core, interaction would work.
One of the main uses for a thing like this that I can see is like validating user inputs. Mm-hmm. Of course.
Yeah, definitely on like a form.
Yeah, right. Because like, of course, it's not as useful. I mean, definitely it's cool, but it's not as important to validate. That's what TypeScript does. It validates local assertions about what your code is doing, but you don't know what a user is going to pass in at runtime sometimes in some situations, and you can use it for this.
Yeah, exactly. So that's the idea and the eternal challenge that the ecosystem has kind of done several iterations of evolution on is like, oh no, we already have types defined. We need to do validation. How do we avoid duplicating our types? It's the last thing that you want to duplicate because it's really, really likely to cause bugs and like crashes if there's any kind of desync between like your types and your validation. That's a really big problem. In terms of like, the kinds of duplication that would be like high risk, I would say like your types and your validation is probably the highest risk type of duplication that there is. So people have really wanted to avoid this. And there's been strategies over time like type gen, and then this like kind of like chain syntax and sort of inference from that. And then I sort of view this as like the next iteration of that's like closer to the original types and has a lot of capabilities that the other sorts of inference don't allow. Things like, inferring cyclic types and stuff of that nature, where like if you have some kind of schema where you have a lot of references between your types, like you still have to type those manually in a lot of validators. And so just being able to like write them just like TypeScript and just have them all inferred and then validated is definitely a nice thing.
That's awesome. Let's look at the code. Is there anything else that you'd want to show on this, or can we dive in?
Yeah, well, we can just keep this open, and then we can always go back. Like if we just want to show off some validation scenario, it probably is like the easiest way to do it. Like I could, spin up a unit test or a TypeScript file with watch mode on or something. Actually, but like this is a nice UI.
I do have one question before we go, or before we switch gears a little bit. If I wanted to just take a partial, like if I just wanted the device portion of this type, the thing, with platform inversion, is there an inbuilt way to kind of pick that out or extract those things?
Not yet. There will be. So we actually have this issue that's asked about pretty constantly. I'm sure it'll come up at the top of my search results if I start typing generic, because people ask about it a lot. But this would be the eventual, it would be just like TypeScript. You could define generics arbitrarily. So we haven't even talked about scopes yet. So that's where the really cool features are, in my opinion. Types are good too, but the really powerful capabilities come from being able to define your own types and keywords and things like that. But basically, in the context of a scope, you could define a generic type like this, and then you could map the input parameter, and then you could use it in another type like this. And that would basically be the approach that would be using. I didn't want to just throw in all of the TypeScript built-in generics without actually supporting this syntax, to be used arbitrarily, because I wanted to make sure that the type system that I'm building is really robust and complete. I didn't want to build a half-ass sort of solution that's okay, well, we know that it would just be this exact string and then this, these angle brackets, and we'll check what gets passed in there. So I'm I'll hold off on adding record and pick, and there'll be index axes and stuff like that. Basically, that would use sort of a similar approach there. But that's in the to-do column. Probably the next thing after this big release we're working on now.
Wow. So you're kind of building building TypeScript inside JavaScript.
Yep. Yeah, that's pretty much right. But obviously the big, the really big advantage is just being able to, use it anywhere. And then also, because we just have complete control over this stuff, a lot of people in the community are interested in things like higher kinded types and things. And that's kind of stuff that we could definitely integrate in a fairly straightforward way. I think one of the really cool things about ArkType is that were definitely some like hard problems in getting cyclic inference and validation to work initially, but sort of even though those things like generics and whatever, they sound complicated, but in reality, you don't really have to do anything with your generic until it's passed a parameter, right? You can't use a generic type unless it has a default parameter, which that's equivalent to being passed a parameter. You can't actually use a generic type until it's instantiated. And so even though it seems like it's adding all this, all these levels of complexity to the way the type is inferred, based on the way that scopes work, where you can have an arbitrary set of keywords that are resolvable at any point when you're defining a type, it's actually just one more keyword that you would add on to what is resolvable within that scope. And a really simple example that I am, made available. Actually, this is a good time to transition, because this is one of these things where I'm pretty sure this is maybe still only on my branch. But I wanted to make this, the keyword this, literally available within types. So basically, if you look at this type here, which I'll just, I think, maybe this is just a little bit clearer. So you can see this is in our test or whatever. But essentially, I wanted to give people an easy way to define cyclic types without having to use a scope. So if you are using a scope and you can define whatever keywords you want, you can just refer to the initial keyword that you've used, and you've created a cycle, and it's fine. But for a lot of people, probably not the people watching this video, but for people who are just learning about it and have used SOD or just whatever thing before and know a little bit about TypeScript, scopes are probably something that I do not want to immediately give them the sort of mental overhead of trying to wrap their heads around. I would like people to be able to do a lot just using types. You can do a lot just using types. You can actually do anything just using types, except for cycles between two types. You really have to use a scope to do that. But basically, I wanted it to be a really flexible system. So I added this keyword where essentially it will always resolve to the root of the current type definition. So if I say let's say that I got some data, we'll do the same approach that we had before, where we have data and problems. and then disappointing GIF. So whatever, we pass something into that. And so if I say data dot, and then you'll get the type there. And let's see, and you can see that even though it won't show the cycle here because it doesn't want to give you like an infinite, an infinite summary of your type. Like this is all type safe. So if I go ahead and like delete something here, you get type errors, and so that is like a very clean way, I think, to be able to represent cyclic types. And of course, you can like do crazy TypeScript stuff with it, and it works pretty well. I was messing around the other day with what happens if you give it some nonsense like this or something, and so this one, I think in 5.1 specifically, they optimized it, or maybe it was in 5.0, but they optimized it so it would just like not try to infer this in the first place. But like in 4.9, it would be like, it would give you the full set of basically it's just like a bunch of nested empty arrays, and you can still do crazy stuff like this to like trick it into thinking it's not just like immediately a cycle. So I think if I like put it in some kind of union or something like that, and then you can see now that it's like, oh yeah, let me give it a shot, and then it's like, all right, it's like infer a bunch of empty tuples. But like it's really robust, and it's really, really fun to play around with. So I've definitely had a ton of fun building it.
Why didn't could you undo one time or you didn't have to specify label on line 13? On line 9, it has to have a string.
Yeah. Okay. So this is something that I should clarify. So again, this is another case where like I am just assuming that this is like fetch data or something. Like I just put that in there because it was trivial to do. But the input type of this is unknown. I think people have actually asked, and I plan to add in the next release something which is not actually, it's very easy to add, but it'll just be like type, rather like in this case, it would be like disappointing GIF dot from, and then it would give you like the type input safety. Awesome. And it wouldn't do validation. But I would say that there's like a pretty strict divide between like, if you actually know the type of the thing that you're, passing in, you probably don't want this validator to be running at all. So I want to, make that divide pretty clear.
I'm glad I asked. Yeah, it makes total sense. Yeah. Thanks for explaining that.
So from a code perspective, I would say that there's two like very unique aspects of ArkType that don't really exist anywhere else. So those two things are the static parser, the thing that like guarantees that you get the same parse output at runtime and at compilation time for like arbitrary TypeScript expressions, and then also the type system, which is what actually does the like deep computations of, okay, if I intersect this object with this object, will I have any like unsatisfiable required paths at some nested point? And like basically what a type system in general comes down to is the ability to like take any two arbitrary type definitions and say like does A extend B as a type. Yep. And so like being able to implement, being able to like have that knowledge as a validator gives you the ability, again, to do like meta level stuff as a library programmer, but also just to make like optimizations when you're doing validation. Like a lot of validators kind of struggle with things like discriminating unions no, they don't do that at all. They'll struggle with just like giving you the ability to discriminate your own unions. Like you have to pass a key directly to say like, this is the key you should use to discriminate. And then you pass some shape or something like that.
You have to do stuff that you wouldn't do if it was just part of the language. Yeah, we have things.
Yeah, well, exactly. So like in TypeScript, there's no like there's nothing direct that you do to like discriminate a union. You just define a union, and if that union happens to have the property that is some key in common that you can use to discriminate, it will discriminate it for you. I'll be honest, ArkType is a lot better than TypeScript at discriminating unions because it's like very thorough. Like it's, when you described Elm and you're like, it will like handle it perfectly. Like when ArkType discriminates a union, it basically looks at all the intersections at all required paths and says like, okay, what's every possible combination of two required paths that results in an unsatisfiable type? And like, we're going to choose the most efficient set of those to check in order to discriminate the union. So even if it's at like a nested path, or it's not directly like a type, if it's some other property or something like that we can use. We don't support every type of thing we could use to discriminate.
Could you show some of the code for what you're just describing?
Definitely. This is so in the weeds, so I feel kind of bad. But I know people should be like nerding out about this.
Don't. That's what I want to do. Yeah, that's what this video is here for. I think is like let's get into the weeds.
Okay.
No problem.
All right. Yeah. So basically, this is kind of like what the discrimination algorithm looks like. So you have two sets, or you have this like set of branches, and the goal of this is to determine the like optimal, in this case, just the optimal next discriminant based on that set of branches, because it will work recursively, so that like if it has to do a few sets of discrimination to like get to which branch it's on, it'll do that also. But basically what you can see is it's like iterating over like a left branch and a right branch, and it basically intersects them, and all these results are cached and everything. But basically it intersects them, and then the main properties that we use for now to discriminate, because this is like what you would want in 99% of situations, is either like a domain, meaning it's like a string or a number or a Boolean or an object, like sort of like type of, but more TypeScripty. What it actually is about is like basically like the TypeScript keywords. We've done a lot of stuff to like mirror the way that TypeScript works. And there's like a lot of subtle differences between TypeScript and JavaScript. You know, one you'll run into all the time is like object and null and things like that.
Yeah.
But it's basically based on like all the like lowercase type keywords that exist in TypeScript are domains. So like it's null, undefined, object, string, number, Boolean, big int, symbol. And I think that is everything.
Object.
I don't know. Yeah, maybe if I didn't say object, then that's definitely one of them.
Oh, maybe you didn't. I missed it. Sorry. Yeah, I was trying.
I have no idea. Function is also an object. Notably, again, like a difference between.
I meant the lowercase o object, but yeah. Anyway. Yeah.
Yeah, no, I mean that's true in TypeScript also. So like you can assign a function to like a lowercase o object. It's just it basically object in TypeScript is anything that's like not one of those primitives that I listed. So even though function, like you use type of a function in JavaScript, it'll give you function. In TypeScript, like that's still assignable to the object keyword, and there's no like lowercase f function keyword that you can use.
Right.
You can use an uppercase function, but that's the equivalent of like Boolean with a capital B. There's all these like nuances. When you're trying to build something that like really parallels TypeScript, you really have to go into the weeds on like how does all this stuff work, and like what's the exact definition TypeScript uses for this, and especially when you get into like how it works for key of. You know, I had a lot of fun like implementing the like prototype traversal and like mimicking TypeScript's algorithm for doing that stuff. Because, you know, it seems kind of arbitrary in some ways, like, oh, if it's a, you know, object, we won't include the prototype. If it's a primitive, we will include the prototype, but not the constructor. You know, whatever. Just it's pretty crazy.
So do you look at the TypeScript code, like when you're kind of benchmarking is the wrong word, but when you're sort of contrasting how to build something, are you looking at the TypeScript compiler?
So not usually. I mean, I think in general, I don't want to. There is like a line that I will sort of draw where I'm like, I don't want to adopt all of TypeScript's mistakes. Like a good example in my mind is like numeric keys existing in TypeScript. That if I say like key of an array, it like gives me a number, and I'm like, no, it's not right. Yeah, I mean, it's just like something that I think probably they did before they had like string literal or template string literals where you could like put a number in a string and that would be something that would be enforced, because like that's really what it is, right? But like it would be pretty easy to like dynamically just allow that type to be accessed via a number. Like you could say, okay, I know that a number will be safely coerced to that string, so I'll allow that here. But when you do key of an array and you get back number, first of all, it's not even enforcing anything about it being an integer, so like, or a positive integer. So you can do like if you check the like type of string array like at -1 or like 0.1, you still get string, and like it's just wrong. So like I am pretty, again, perfectionistic. So like in these kinds of scenarios where I'm like, I know that it's wrong, I'm not like looking at the source to be like, okay, well, like let me make sure that I'm like copying how it's wrong. It's a really tough balance, because there are some cases where I feel sort of pigeonholed.
I once had a big argument with a colleague many years ago, like almost 10 years ago now, in the office about this exact topic. And he was a super advanced, still is like miles ahead of me, engineer. And I learned a lot from him. But this is like the one thing I knew. And he tried to tell me that you can use numbers as keys in objects. And I said, no, I'm sure that you can't. And We did what you end up doing in these kinds of conversations. We tried to like prove it with code. But what he did was showed that you can set the object as a number, and then you can access with a number, and everything is there and it works. And
Yeah.
we ended up having to do like object.keys on the thing and then get the type of those things. And he thought that was just a weird thing about object.keys, but not necessarily indicative of much. But no, it's not at all. In JavaScript,
It's true.
At the time, this was before,
they're all strings.
This was before ES6, so there were no symbols. So at the time, you could only have strings. So.
And I think object.keys will still only give you strings. I think that you have to do like object.own symbols or whatever thing that it is if you want to get the symbols. But it's true that there's like this idea of like a numeric key is not real. And TypeScript was also not precise in defining it to like only check the indices that you should actually be interested in. So like those are things where I'm like, okay, this is like overtly giving me the wrong result. Like I'm not going to adopt that.
I'm not gonna lie, I got a little defensive when you said TypeScript's mistakes, and then you listed that one. I'm like, yep. That's a
I love TypeScript, and I think it's a great language. Of course, I love the like flexibility. It's also like massively complex, and it also has to adapt to the JavaScript ecosystem, and it's a mess. And there's tons of legacy stuff, and people have been using TypeScript for a long time, so it's not perfect. There's no way that it could be perfect. I think it's amazing for what it is. But if I'm like building a type system from scratch and I have the ability to like, see everything that's happened over the last 11 years and, build something that's slightly more accurate in some of those situations, like I'm not going to write code that I know is wrong, basically. I might write code that I don't know is wrong and then it ends up being wrong and then I end up being the legacy system someday and then someone else is like, I'm going to write something better. But for right now, like I am the person benefiting from like the knowledge of the last 11 years. And I'm like, look, TypeScript, you screwed up when you made numeric keys. There's no doubt about it, especially as someone who's like really into type systems. Like you do not want two ways to represent the same type. You do not want to say that like one, the string and one, the number is the key of something because like it leads to all kinds of problems.
Yeah, what about 1.0 then?
Yeah, no, that would also.
No, that's what I mean is like you open the door to these questions. Is 1.0 also the same? Right. Because then the string and number representations are different. I mean, semantically, right. But could you show us the code about what we were talking about a few minutes ago with the the string or number in the type properties? How do you do that? How do you do that autocomplete? Do you know what I'm saying?
Oh, yeah. Sure. Okay. So yeah, I think maybe it'll be more interesting for people probably to like look at the some of the like parsing stuff because it's actually more approachable when you look at it. Like the types are very different than probably what people are used to seeing, but like it's actually not that hard to understand. Like we're not using like T and U and whatever. It's like maintained like normal code. So there's like actual names of things and you have to. It's like when the scope of something is this big, like you can't just use like, single letter names for all your variables and expect people to look at it and know what it means. Like at a certain point, you have to start maintaining your types as if they were functional code. And so you see probably some of the differences in terms of like our conventions around casing and stuff like that. And it's really just to like mirror our functional code. And this is kind of really nice property where like if you do define a type and a function with the same name, you can actually import them at the same time. And then depending on like whether you're in a type context or like whether you're at a runtime context, like TypeScript will appropriately resolve it. And so it creates a situation where you like define, I think that in this case it's like a slight sort of there's a slight shift because at runtime there's just this single like parse operation that gets called. Whereas, for at compile time, it's actually split into two steps. There's inference, where we extract out what the type of your definition is. And there's validation, where we, recurse in your definition and make sure that every part of it looks the way that it should. And so that part's pretty different. But if we start to like dig into what happens when you actually start to like iterate over the characters of a string and parse those, it's like this, it's this very nice, like beautiful, in my mind, kind of like parallel between what's happening at runtime and what's happening in the type system. So you kind of get an idea here that like when we are at the point where we're like, okay, we've in our definition, we've like found either, the string, like string or numbers or something like that. This is where we are. This is where we are at runtime. And this is where we are, in the type system. And we just iterate over, parsing like one operator or operand at a time. For those who aren't super familiar with like syntax terminology and everything, just being like any kind of reference to something would be an operand. And then the operator would be something that performs some action on it, like a pipe character for a union, or an and for an intersection, or an array operator, anything like that. But basically, if you start to like delve into how this stuff looks, like these are kind of some of the like most beautiful parts of the code. I think is just like this kind of stuff where it's like parse operator, and you look over here. This is some like internal syntax that we use. You can tell that I think it's beautiful because I use it for snippets. When people ask about this, just extracts it so I can like put it in documentation and put it other places. But basically, like I think it's a really good example of the like isomorphic parsing, which is I'm going to zoom out just temporarily. I will zoom back in, but like so you can see both at the same time. But basically, like you can see that even like the shape of them is the same, and they are literally performing like identical sets of checks. Like these have such a strong parallel between them, and it's like for me really beautiful to like look at what the runtime code is doing and look at what the compile time code is doing, and like see the exact same implementation, for the most part. And then also, of course, we test all the results, like I said, to ensure that the output is the same. But that's kind of the way that we approach a lot of this is like, once you work with the type system enough, like it really is, a reasonable way to like approach solving most runtime problems. So this being like a full sort of like shift parser that's capable of like, parsing arbitrarily nested expressions and all that stuff. Like, and I can kind of, show some of the like tests for those things. It's
pretty amazing what you got.
Just stuff like, let's see if I can find like any good ones here. So like this is an example where basically like we have this type. Normally, if you were defining something like this, which like just don't, but like normally if you were defining something like this, you probably have it on its own line here. But if I like assign this to a variable or whatever, then like you can mouse over this and just see it's just immediately, you can just get it as like this exact, it's a one-to-one. And like that's because like that expression is sort of like, optimally parenthesized. Like if you add in extra parentheses arbitrarily or something, obviously, the type will get rid of those for you. But like any sort of like correctly grouped and optimally grouped expression, you can just mouse over it and like see exactly what it is. You can have just like, whatever. You can nest like 10 sets of parentheses if you want. And there's some like benchmarking tests we do where we do some weird stuff like that for like type instantiations and all of that. But like basically, it really is just like a full parser for this kind of like arbitrary syntax. And I will say that I think that the coolest thing and like the biggest innovation, which like this is pretty advanced compared to like, probably a lot of TypeScript, implementations of various like static inference stuff. But like, I think what really like opened the door for like all kinds of, interesting possibilities is like this idea of like semantic validation, which we eventually got working. And excuse the fact that I have a bunch of commented out tests because this is a branch that I'm actively working on. So I probably need to convert some of those over. But basically, you can see here that we have like this big suite of tests for like parse errors. This is for range checks. So like in addition to the kind of like built-in TypeScript syntax, which let me zoom back in here for you.
Thank you.
I'm sure you would have asked me momentarily. So basically, in addition to the built-in, which you can see like right away, like all the keywords that are available by default, if you just start, defining a type.
I love some of the. I just want to look through this list. Credit card, alphanumeric. There's some cool ones in there.
Yes. Yeah. I want to give people like a lot of useful validation. I am hesitant because what you'll find is that people are very opinionated about the way that certain things are validated when it's not like concrete. And email is a great example where like, how much do you check? Like, what about these edge cases where people have crazy emails without a domain suffix? Like what, I don't want to be too opinionated when possible. So like I want to hit the major ones, and like email, I feel like I had to commit to because it's such a common thing that you'd want to validate. But like at some point, it's really easy, as we'll take a look at hopefully at some point, to be able to define your own validators, to define your own validators and define your own keywords. So like given that it's so easy to define your own keywords, I feel pretty safe just telling people like, hey, if you want a different regex or like a different way to validate this, then like you can just add it and you can use it. But like the ones that are built in,
I see.
I do want to cap it to some extent.
And that is where scopes come in, right? If they want to create a new one.
Yes, so that's right. So I'll show this like semantic validation thing real quick.
Got it.
And then we can take a look at scopes, which I think are like the kind of the coolest part of this. Well, I said that about semantic validation. They're related, you know. Maybe I just really am excited about
it's
all
all
of it. So
cool. Hey, man, don't worry about it.
But okay, so basically, like this is a good example. So let's say that I have credit card. So this is going to be inferred as string, like all the runtime validation stuff. You know, maybe we could give some like crazy template literal type or something like that. But in general, probably people just want to know that it's a string. And if you wanted to do some kind of task to something like that, like again, those are the kind of things that I don't really want to be that opinionated about, because like most people maybe don't want whatever that mess would look like if I try to make it a template literal. But like basically, you know, obviously all the like built-in TypeScript syntax is available. We'll see if I can use the like 2/queries thing, and maybe you'll get some kind of that's nice. We'll see if hopefully it'll stay up to date. Sometimes I know it like won't update when
I've hit that as well. Yeah.
Yeah. Okay. Anyway, so basically you can kind of see what's going on there. But what you'll notice is we also have some like runtime operators. So as opposed to just being like validation keywords, the main ones are divisors and ranges, which are things that like we're not using them to change the type itself, but at runtime they'll be validated. So if I try to say like a credit card less than 10, actually that's going to be valid because credit card is a string. You probably wouldn't want to use that, but like let's say if I wrote like Boolean is less than 10. So this is the semantic validation. You can almost see it here, but we're a little too zoomed in.
Gotcha.
But you can see that the error is like this really beautiful semantic validation error that says bounded expression Boolean must be a number, string, array, or date. And it's also not just doing that based on like, oh, is it like one of those keywords? It's actually inferring the type that's in the expression, because if I change it to say Boolean array less than 10, it's good. So it's actually like inferring the type that's in the expression and will give you parse errors at that point, like based on what the inferred type is. That is like what happens in your IDE. That's what TypeScript does. Like basically is like infers the type of an expression. This syntax step that says like, you know, okay, are you missing a curly brace or something, right? And then there's the semantic validation step where it says like, what about the meaning of these symbols? Like, did you try to assign a string to a number? So the fact that we have the capability to do semantic validation means that like whole world of stuff that we can do where we want to say like, hey, I want a generic and I want the input parameter to extend string. We could do all of that like just from within this system.
Could you hit backspace twice?
I think it's a really
could we see that error again?
Yeah. So it says bounded expression.
That's really amazing, because what you're doing here is you're creating a string that actually is an error message, and like you're kind of making your own TypeScript compile errors, like you're kind of plugging TypeScript on the fly. Can we we have to take a sidebar. Can you show me like how do I do this in my libraries? This is super good. This is a great user experience.
Yeah, I think it's the best option that we have for giving like validation level feedback within the type system. There is a GitHub issue in TypeScript for throw types, which would be like a more sort of official way to say, hey, this was just a problem. That would be great. It would just mean that like whatever edge cases you might have to worry about overlaps and about like propagating your error correctly and things like that in deep scenarios, like you wouldn't have to worry about. So that'd be awesome if they merged that. But in the meantime, I think this is like the best possible approach. So basically, at like a high level, what you would write is like, let's say that I have a type called parse, and it takes in s, which is a string, and then so I can define whatever like arbitrary set of rules that I want for my string. So I'll say that like, you know, maybe does s extend foo, and then like infer tail or something like that. And then we'll say that if it does, maybe we'll, well, in this case, like so this is really more of like a validate kind of scenario. So I'll just change this. I'll say like validate s string, and then we'll use it in the function. But basically I'll say that like, instead of even doing this, because I don't need to for now, I'll just say, does it extend foo and then some string? And if it does, I'll return s. And then otherwise, I'll return
your error.
Probably an error message that would probably say something like string should begin with foo was s, right? That's the typical kind of like structure that I'd use for a message like this. And then I can write a function where I say, let's do the isomorphic thing, and we'll call it validate. And so we'll say s extends string. And so here we can, have a parameter called s. And then we'll have to see how the narrowing treats me for this kind of situation. But we'll just return s if we'll just return s either way.
Yep.
So we'll see what happens when, so string should begin with foo was, looks like there's an extra parenthesis there or something, or maybe I'm just parsing it. Oh, it was an empty string. I see. And then that's the end of it. So, okay, great. And you can see that it updates. And then hopefully if I pass in this, it will give me the valid result. So I would definitely recommend that if you are a library author or something and you're wanting a good way to like give type level feedback in terms of whether some input was correct or not, number one best option is just to write a type, like write a normal type that's an input type. If you don't need it to be generic, then just like you can just rely on TypeScript to tell someone, hey, like this should have been a string and it was a user. Or like in a case like this, you could just type your input as like foo string, and TypeScript would just say like, hey, your function input wasn't assignable to foo string. But if you're doing more complex stuff like this, it doesn't have to be this complex, but there's a fair number of scenarios where you actually need to like do more detailed analysis of what the input was, and then give some kind of feedback. I think this is a really, really helpful pattern for making it obvious to users like what went wrong, because what you'll see oftentimes in like complex types for people in this situation is that instead of giving this error message, they would just say never. But then obviously, like, it's just a lot less useful. You don't know what to do at that point. Like if all the ParseErrors said that, then like no one would know how to fix them. So I would highly recommend an approach like this.
Amazing. That's such great usable stuff. I'm going to use that today. I mean, that's really, really useful.
I'm glad. Awesome. I hope that people do implement that kind of stuff. And so, yeah, basically, I don't know if we'll need any of this again, but basically, this ability to do semantic validation was like the last thing that was kind of unlocked. Like we had syntactic validation. So that the big difference is like that actually occurs during parsing, the syntactic validation. And then there's a separate step where like once we actually parse like into an abstract syntax tree, which we have like a type level representation of, and then we have a runtime representation of, then at that point is where we like go into the tree and say like, okay, look at the different types of expressions, and like I found like a bound expression, like then go ahead and infer the operand of that bound expression and make sure that it extends string or number or array or date or whatever. And if it doesn't, then just return this error message. But you can start to tell that there's like a lot of cyclic kind of stuff going on here, because the idea of like inference and the idea of validation are very related. Things that are not valid are going to be eventually inferred as never. And yet, like, we rely on the validation result in order to perform the like semantic validation checks. And so there's like very specific ways that you have to approach these things, which are remarkably stable in the TypeScript compiler. The only time that I've actually seen anything break, like, and I've been working on this for a year and a half, after, I will say that like when I first started working on this stuff, it was a total S show. It was a mess, and I was just like throwing stuff at the wall and was like trying to get it to work, and things broke all the time. I think I saw a TypeScript error that was like 100 million characters or something. Like it was just ridiculous nonsense. But as I like kind of figured out the strategies that work the best, like that stuff stopped happening. And like people worry sometimes about stuff like ArkType. They're like, well, it's like crazy types, like it's not going to be predictable, it's not going to be reliable. Well, like if you have all the types tested as robustly as the code itself, they're pretty reliable. We've tested like tons of scenarios, and we've tested really big scenarios where you have like 500 cyclic types in a scope, and it's still really fast to interact with. So it is really robust. And that was honestly a shock to me when I learned that. Like, I sort of went into this thinking of it like, hey, it would be cool for like little types if you could just write them just like TypeScript, but like probably it won't scale that well. But like it turns out that it, if you sort of like optimize the parsing process and you write your generics the right way, it really can actually scale remarkably well also.
Yeah, that's amazing. I'm glad you explained that, because it's easy to look at this and kind of brush it off, like you're saying, because anybody who's done enough of this has been bitten by these things get tough. And but like if you can sort of cover all of your bases and do have enough test coverage, I mean cover in the both sense of the word, I think it's pretty compelling use case.
I think what we really need in the ecosystem, so shout out or pitch to like anyone who's interested in working on something like this, is like a type branch coverage tool. I would love that. Like if I could see branches of my conditional types that were like never hit, for example, that would be incredibly helpful. I don't think that anything like that exists as of yet. And I think like most of the like innovative kind of like test level tooling around this type stuff has like I've had to build it myself. And we're working on being able to share some of that with the community. You can see that like stuff like this, attest is like our test framework that we built, and it's like ArkType Test kind of. So it's like a little clever pun.
Oh, that's funny.
But basically like this throws and has type error thing is really, really nice, where you can see that well, first, I'm not like duplicating the strings, first of all, which is good. But essentially, it will just check that like both when it does static analysis and checks like if I uncommented this, like what the actual type error would be. Like single equals is not a valid comparator. Use double equals to check for equality. And then at runtime, when you go to parse it, like both of them will contain this specific message. And so that just makes it really, really easy to test all these like isomorphic parsing scenarios to ensure that the output is exactly the same. Wow. And then there are some things that it like will only tell you at runtime. Some of them in the past, I was like, I could like do crazy stuff like discriminate unions at a type level, but even I have my limits in terms of what I'm like, this is too extreme. I don't want to maintain this. Like, because that was something where like tech would make a change and I was like, oh, like this is a little fragile and like it seems crazy. Probably just waiting for a runtime error if you do some nonsense like, okay, I have like a deep intersection with two morphs at the same path. Like, sure, I could write the algorithm at a type level, and I did, and it was working. But like, I'd rather not maintain it when someone can just run it and get the parse error right away. So like, There's a couple things like that or whatever. Like, the runtime features are really powerful. Like, if you intersect two ranges where you say like a number between 1 and 5 and like a number between -3 and 0, it'll say like your type implicitly has an empty results, unsatisfiable. So like things like that, it's like a really powerful type system.
Oh, wow.
I would not. That's impossible to implement in TypeScript, at least like to arbitrary sort of precision or what. Like you can't represent all numbers. You can. I mean, you can only really represent like a set of integers, and maybe you could do some algorithm where you. But that's we're not going to like do that because there's limits to what you'd really want to like statically know. But again, the like dynamic power of it, or even like parse results you get back, are incredibly detailed. They're like this type level of specificity plus whatever the extra stuff is that we get by like deeply computing all the types and all that stuff.
For sure.
So.
Wow. That's amazing. I want to wrap it up somewhat soon, but I'm still anxious to see. I want to know how you did the like. Where's the code that does the ORing? Like if you have string or number in the type.
Yeah. Oh, well, my bad. I'm sorry. It's just a reflex.
Okay. It's taken, I've been, it's funny. It's funny to watch. Actually, I've been doing this, like streaming and live coding thing for a few years, and when I first started to take on that goal of like making it easier to see for people on phones and people, I felt so constrained and so claustrophobic. It's like I just feel like. Anyway,
I'm so used to like the environment being the way it is that if anything changes, I'm like, oh, this is not right. Or like the same thing, we did that type challenge, and I was like, it doesn't format when I save it. Like, I like get so used to that because I'm like, if it doesn't do that, then I know there's like a syntax error. Like I have to fix something. But
okay, so this is it. We already looked at it. So then, okay, wow, it's just like I'm just awash with all of the things that you're showing.
There's a lot going on. Yeah.
So
okay. So this is where like it checks and finds that like the next. So at this point, the state there's this like state, which is a parse state, and what it would have at like a high level, since we don't have infinite time, is that it will have like a representation of what the current branches are and that have been closed, what the current groups are. So that's like how it keeps track of parentheses. Like if there's an open range with like a left bound that you haven't completed with the right bound, there's like a bunch of stuff in a parse state. And so when we say like, oh, okay, we encountered like one of these branch tokens, we use this like state dot reduce branch. This is a namespace, by the way. Our namespace, like again, you do a lot of stuff at a type level that you're like that won't even compile because it won't be included in the compiled output because there's no values in it. So TypeScript just omits it entirely. But basically, like this is we use a namespace so that we can conveniently access a bunch of methods on a state the same way that we would access them at runtime, which is kind of cute. But basically, it will reduce the branch, meaning it says like, okay, look at the current state. And then, I'm going to give you like the branch token, which will either be or and then I'll give you all of the remaining characters. And then that will create at a high level, basically, it just leads to like this abstract syntax tree. So you said string or number. What it will produce is this. And then like in the final validation and inference step, we will actually go in and say like, okay, string or number, and then that's what you get out. So that's pretty much the way that it works.
Okay, so then all of the things, so I see that it recurses on a lower, like line 48 there, it recurses there. But then it must mean that reduce branch and finalize group and all these other things also call parse operator somewhere. Is that it?
So back at the sort of like top level of the string validation here, this will kind of like put some of this in context. You have this like loop, and then you have this next thing where you say like, if the root is, and this is such a nice simple thing, but if the root is undefined, then you parse an operand. And if the root is not undefined, then you parse an operator. And so it's like really easy to just divide it into these two categories of like, either we have something we can currently operate on or we don't. And like TypeScript syntax mirrors that very well, where like if you already have string, you don't want to just accept like a token number, like string number is not a thing. You need like some kind of operator that would do something with string. And so this is where actually all the looping happens, is we are basically saying like S extends this is like a state that is not done. And you can actually see the shape of it there. We've got like a group, we've got branches. The groups are like, kind of like stored previous states from parenthetical expressions. And then like the string part that we've already scanned, and then the unscanned part of the string. Okay. And then so we wait and see like this. If it's ever not a static state, it means it's done. And so then we just return it directly.
And the $, is that like an accumulator or a higher kind of type or something?
So that's the scope. That's just a convention that we use because it's everywhere. You'll see like in the repo, which is probably why you mention it. But we just wanted to not like you probably increase the code base by like, a few hundred lines if you call it scope or something. So like it was just a convenience.
Have you ever done Angular 1 development?
No.
Really?
I'm not sure. Yeah,
that's going to be so funny. I'm happy to be the first to tell you then. In Angular 1, there's this cursed thing called scope. And it's obviously has a different purpose, but it was a big part of Angular 1. And it's kind of like a global state. Anyway, but there's a lot that you need to use it for. And they also chose to use $sign to represent scope. So or I guess you would say $scope. But I just think it's kind of funny that, anyway, there's that crossover. So you have some Angular 1.
Somewhere out there, I have some, soulmate who had the same intuition about scopes as me. And you can see that a lot of time we're using S for state. That was like part of the reason also. I'm like, I don't really want to use S again, because like that's kind of a convention to use S for state.
For sure.
So I'm like scope. But that's great. Yeah, maybe like the last thing, or if I'll just let you determine the amount of time and everything that we have. But like we should look at scopes at least a little bit, because I feel like that
for sure. Let's do it.
It's such a powerful tool. We'll see if these types are if these tests, maybe a better way to view it would actually just be in like the scopes example here, so we could even do some of the validation stuff and see how that works. Okay. So this is probably a good one actually. So I'll zoom in. I'll open this in its own window and everything, and we can take a look at it.
Thank you.
Yes. This was. Oh, let me get rid of this, and then. Okay.
Great.
Maybe I can. Yeah. Okay. Okay, so I've got some little notes here, I guess, too. So yeah, basically scopes are a way, they're much like scopes in the imperative code you write in TypeScript. It's like you can define a set of keywords that are resolvable within that scope. So instead of the normal, like if I wrote this as a type, this would be like a key of the object, and this would be another key of the object. Because I'm in a scope, it's like one level up from that. So like package is now a type. And then this is the definition of package.
Okay.
And contributor is now a type. And this is the definition of contributor. And I'll just delete this just because it's kind of getting in the way a little bit. But yeah, basically you can see that in this scope, the package type refers to both itself here. So like dependencies is a package array. And it also refers to contributors here. And then contributor refers back to packages because it has a reference to the packages that person has contributed to. And if you mouse over it, we're a little zoomed in where it's not very.
But it would show you
cooperative. There we go. So we get one level out. Then you still get the like really nice clean inference of like that's as clean as it could be represented. Basically, actually, it would be cleaner if it had exact optional property types enabled, so it didn't have to do or undefined for everything. But nonetheless, essentially, like, and again, you see the same pattern where TypeScript will always represent cycles with that like ... if it doesn't have an alias for a name. But essentially, like you still get the sort of like full type safety. So if I say like types dot contributor, you'd use it. It's just like a normal type, right? So you pass in some unknown data, just like we did before, which I guess I actually probably have an example of here. So I kind of constructed the data purposefully here because I wanted to showcase the fact that like not only do the types work in terms of cyclic inference, but we can also validate cyclic data. So like in this case, you can see sort of that I am setting the first dependency of the package to be itself, so that that if I wasn't like handling the cyclic case, it would infinitely recurse trying to validate it. But we keep track of all the references of the things that we've seen before, and you can know that like if you've made it to the point where you've hit a cycle and there have been no type errors at that point, that you are in a valid type. So yeah, basically this is like an example of it using that. You have your collection of types, which includes in this case, package and contributor, and then you pass in some data like this, and you can see that we get some problems. It says dependencies 0, dependencies 0, contributors. Email must be a valid email. I put a lot of arrays in here so you can see this, and I want it to be lazy and like and not make them a million things long. So they're all the first element or whatever. And then contributor 0 email. This is like maybe somewhat. I guess it's like I don't even. This is probably a bad example to give in terms of like this is super clear. It's giving this error because it's like technically the error is like both part of the package type itself and part of like the nested
because they reference
email
each
validation.
Other.
Yeah, but essentially, if I went in and changed this to be something that looked like a real email address, and you even see like in the validation, it will stringify it correctly. If you actually got the data out, it would be the cyclic reference, but we built some stringification, whatever code for like this and for our sort of internal logging and stuff. So you can see that there's like a cycle at this point, and it references dependencies. So
I'm struck by how many libraries there are inside of this library that you've built. I mean, just what you mentioned there about handling the cyclic references. I mean, there's like people, that's their whole thing, is just making a stringifier that does that. Or the attest stuff that you were showing. I think there's a great need in the TypeScript world for something that does exactly like that. You mentioned.
I can give a quick preview of that also because I know a lot of people are interested and a lot of people have like reached out, like type level people, like the TS pattern and like hot script and stuff like that, like like those kind of like really deep type level packages like have a need for this kind of stuff, and especially the like type level benchmarking. So for example,
that's the next thing I was going to say is the benchmarking is like super needed.
So we did this, like does runtime benchmarking as well. And basically, you can see that like this particular scope of 10 cyclic types. So like it's just some auto-generated data that just refers to itself in like every type just to kind of simulate some like very complex schema or whatever. Results in 3,369 instantiations, which in and of itself, you're probably not like, oh, like I know what that correlates to or whatever.
Sure.
I mean, it's very fast. It's not a problem. But the good thing that you can see is that basically like it'll end up scaling linearly. So it like scales with the number of types in the scope, like the number of instantiations, not with like the number of the types squared or anything like that. So it means that it's like you can really expand the scopes to be really big. So this is like 100 cyclic types. So you can see just this like arbitrary kind of like mapping of all these different users and stuff together. And so I just for the sake of not having a massive file, like I have it defined externally, but it's just the same kind of definition syntax of like name is a string, friends is an optional user array. And so basically like, I like just from scratch, if I like define something like that, and then I start typing, like this is the kind of like responsiveness you get from it. Like it's actually just instantaneous.
Wow,
there's like no delay whatsoever. So like it's really amazing. So that's like 100 cyclic types. 500, you notice a very slight delay, but like it's still really fast. So like faster than like a lot of really trivial stuff that like people do. I guess that would just be a Boolean, but like if I wanted to keep going into something recursive or whatever, my typing got worse. But like it's still really fast to do 500 cyclic types. So it's like it really scales very well.
Wow, that is something. I have we should like each of those are worth their own like spotlight showcase video, I think. But this is really incredible stuff. I mean, just wrapping up, I want to know kind of where you would like this project to go in the next like year to 3 years, I suppose. It's JavaScript, so it would be hubris to ask for any more than that. And the second thing I want to know is if there's anything in TypeScript itself that you think you would really like to have, or that you feel like you're missing to build stuff like this.
Yeah, well, I definitely think that I mentioned a couple things that I was like, oh man, it would be so nice to have like throw types or whatever. And if someone asked me that and like was a TypeScript genie or something, and I could actually choose like one feature to have, I would have to like one that I've thought about a lot is like the ability to iterate over the members of a union or the branches of a union like directly. It's so easy to go from like a tuple to a union, but it's really a mess to go from a union to a tuple. It can be done, but like it's a mess. And
it's one of the TypeScript type challenges. Yeah, we have a video for it, and you're exactly right. It is some scary stuff.
Yeah, and you don't want to do it if you're like caring about stuff like this, because like it is not efficient. And so like there's very specific strategies you use and like things that TypeScript handles really well. The whole structure of our parser being like a shift reduce parser, where instead of like matching against template literal tags, it iterates over one character at a time and updates a state. Like TypeScript's really good at that. TypeScript is not very good at saying like check if the string matches like this or this. It's just not efficient at like inferring those parts of the type. Maybe they could optimize it, but it just turns out that like this like one character at a time parsing stuff is much more efficient. So we've like gone through a bunch of iteration cycles on this kind of optimization stuff. I think if I could pick one thing that would be sort of that maybe I feel like would be the nicest overall update from like in terms of the user experience that I can create within the context of TypeScript. I think what I would want is the ability to explicitly provide auto completions while still like giving a type error if like someone doesn't, because I had to choose between those two things. And the autocomplete is so nice. I think in the end, there's like no question for developer experience, like which one is better, but it's lame if you like type an empty string and it's like not assignable to these 36 things or just like whatever, like that's not a great error message. It would be really cool if there was a distinction between autocompletion and like the computed result of a type, and that like the autocompletion result would only be populated in the context of like a editor scenario. That would be awesome for me. I'm being selfish, but like that would probably be the most helpful thing.
That's the question. Yeah, be selfish.
Yes. Okay. So I know that you asked what was the one thing I wanted.
Yeah, like where do you for ArkType itself? Like what are your dreams for the next year to 3 years? Like somewhere in there.
Yeah. So well, I've been working on open source stuff for like the last almost 4 years. And so this was like the latest evolution of that. And like I said, I'm so passionate about it. I'm so happy that I found it. Like I definitely do not want to pivot. But like basically, I used up a lot of my savings. And so like I'm pretty interested in making money so I can like sustain the development of this, because there's nothing I want more than to be able to continue to develop this and to like see it sort of like reach its capabilities. So my goals currently, in terms of like, I think probably the most efficient way to go about that is to pursue like VC funding and to pursue like building basically like web-based tooling for like validation. Is actually really lucky. There's a validator called Pydantic in like the Python ecosystem where they just got $5 million in funding from Sequoia to, basically take their like Python validation tooling and like build web infrastructure around it. And I think specifically there's like really powerful opportunities with instrumentation, like code instrumentation, and there's all this like AI generated code stuff, but like how do you know it actually works? Well, like if you have the ability to like validate arbitrary TypeScript syntax at runtime and like check types, it could be really powerful for like ensuring that, without even writing ArkType definitions, basically, that like if you just want to check your code for correctness, like those would be the kind of things we'd want to build as premium features that I see as being monetizable. But
definitely,
like the goal for me, like just on a personal level, is like I think that this approach to validation has so much potential. And I mean, of course, I'm biased and opinionated, but like I honestly think it's like very, very far beyond the capabilities of existing validators. Like not my documentation, that's very far below the standards and capabilities of existing stuff. So I'm trying to work on, getting caught up on that. But like, in addition to all the stuff we've talked about, the definitions are like usually like less than half as long as like most validator definitions. It's like the expressive syntax and semantic validation and optimized discriminated unions. You define the same way as TypeScript and it will, arbitrarily discriminate layers for you. There's like so many benefits. It's also like about 400 times faster on this branch than like Zod, for example, because I've like really optimized the performance and like done this pre-compilation stuff. So I've really tried to like just make every aspect of it like as good as it could possibly be, and like invested as much of myself into doing that as I can. And to be able to like continue to like grow it and like realize the vision at this point, like after I kind of get this release out that includes some of those perf optimizations, and a few of the other features that I think will be nice for people, like being able to like do some kinds of chaining and stuff like that. But basically, I'd want to like pursue VC funding so that like this can be the sort of like open source core of that company, because like I think that's probably the most stable way to like have basically maximize the chance of a big ambitious project like this, like realizing its potential in the long term. Because as I kind of alluded to at the beginning, it's not even like just a JavaScript TypeScript ecosystem that like this has the potential to be really powerful for. Like, because most definitions are just like JSON syntax, you could actually just like write an adapter for this, for Python or for, Rust or any language. You'd have to like change some details about like the way that, certain keywords work or what stuff exists. But like basically it's a serializable definition syntax you can use to check types. So like that could be incredibly powerful for like validation that crosses the boundaries of your stack.
Yeah, I mean, it's exactly what you said. I think there's a lot of value in being able to define these things. It's so powerful to tell people, hey, write your schema, and this thing, like you said, can be JSON style or whatever. I mean, just like write a simple schema, describe how this stuff is supposed to work and look. We'll generate clients and servers and do whatever we need to do in validators for you. And then like, if you need to ship a Python client, you don't need to staff a Python team.
Right. Yeah, exactly.
Pretty powerful.
It's a huge deal. And so obviously I think if you're someone who's like coming from TypeScript, JavaScript, like in that ecosystem, and you have a heavy investment in probably like your tooling around the front end, and you want that like type safety and developer experience, well, like this is going to be super optimized for that. I don't think most languages support the kind of like static typing capabilities that would allow something like this to happen. But like, maybe plugins or something potentially. I think, basically having this at its core be like, this is sort of in my view, like the ultimate validation solution for like TypeScript. And then from there, like you could just, throw your definitions in a JSON file. And if you have to validate your data on the server, then like, we have a Python adapter that like parses those definitions and validates them for you. That would be an incredibly powerful thing. And so like, that's the kind of stuff that like in the long term, I'm really passionate about realizing. And if you know anyone who just like wants to sort of like fund the project to do that, and I don't have to think about all the monetization stuff and everything, then that's amazing. But realistically, if I'm like, what's the most likely way that I'm going to be able to sustain doing this like indefinitely and potentially like grow a team around it, it's probably like also having a portion of it that's like web services and proprietary BS, because like it just, unfortunately, somehow I have to actually be able to continue to pay bills and do things like that. So that's kind of the situation I'm in, but I'm very optimistic. Like I said, I think there's like so many.
The good news is there's a ton of value for companies. I mean, like I don't, it's such a large pie, and it's being so poorly served at this stage in time. I think there's so much that. Also, I think there's a lot of light bulbs that haven't gone off yet for people, that people have not experienced a tool that can do the kind of things that you're describing. And, so they don't know what they're missing, and they just, this is how it is. You have to validate inputs, and it sucks. And that's just what they've come to accept. But it doesn't have to suck. It can be awesome.
Totally. I mean, I agree. That's like that, getting it as close to one-to-one with TypeScript as possible, because I love writing types, and some people are like, I don't like writing types that much or whatever. But if you have to define validators at some point, you have to somehow describe what your data looks like. Then I like TypeScript for doing that, and this is as close to that as possible with those kind of syntax extensions for runtime. I feel like it feels like such a good approach, and a big part of the obstacle in terms of what's going to happen over the next years in terms of whether this is successful or not. And sort of becoming a standard for validation in the ecosystem will come down to whether I can get people past the sort of hump of, complex types, it'll probably break and crash, or, strings, it's probably not very type safe. People have a lot of intuitions about those things that this
seeing is
believing. Very different.
Yeah.
Yes.
I mean, what you've shown here is a pretty compelling demo. So I think if the more of those, I'm so happy that we met, and I'm so happy to show this and have this video, and so people can see a little deeper than the surface level on how this stuff actually works.
I feel like there's so much depth, unfortunately. I'm just it's so hard to cover any of this stuff.
There's so wrapping up on that side, the Michigan TypeScript YouTube channel, this is exactly what it's here for, is to do this kind of stuff. If in 6 months a lot of things have changed, we can meet again and do this all over again, or 1 month, or whatever. It doesn't matter. I think it's free. It's free for you, it's free for me, and it's free for users. For people who don't know, all ads are turned off on all of the videos. Nobody's making any money. It's all open, and I just want people to be able to access this stuff without being interrupted. And I'm not the only person working on Michigan TypeScript. Everyone sees me because I'm making the videos, but there's a lot of things that happen behind the scenes too, scheduling people and all the other kinds of things, and planning content.
That's amazing.
So I'm really happy that we had this time, and thank you for your time. Where can people find you? How can they support you?
So definitely would recommend checking out the ArkType Discord. So I guess I'll probably send you a link that maybe you can include in the description.
I'll put it on the screen.
We have a really nice community of people who are really enthusiastic about the tool and willing to help out with that kind of stuff. And then I'm on Twitter. I actually stream on Twitch pretty often. So if you want to come in and ask me questions about complex types, or see me working on crazy type system stuff or crazy generic types or whatever, I'm doing that pretty often.
Amazing.
And so I'm very accessible. I'll send all the links over, and hopefully people can check those out. I would love if any of you had feedback or just wanted to reach out and say hi. It would be great to hear from you.
Awesome. Well, thank you so much for your time. This has been incredible, and I don't know. I'm just I'm gonna have a pep in my step for the rest of the month. I feel like this is so cool.
Oh, wow. I was gonna say it's really energizing for me to have a chance to talk about it as well. If I can ride that out for a month, that would be massive. I hope that it gives me energy for that period of time. But right now, I'm definitely feeling the juice. So hopefully, can write some good code today.
That's great. Yeah. Cheers, man. We'll talk soon.
All right, thanks so much. Yeah, great.